Hello guys, this is our lab 2.
Oh yeah, what's up, man?
Wala pa mi. Kay dugayon kay among kauban.
Hello viewers, hello world. This is Rob,
And this is Kobe. And this is Roy.
your laboratory buddies. For today's video, we'll be conducting a test on the normal consistency of cement. This test determines the amount of water needed to create a cement paste with a specific workability, which is crucial for further tests and achieving an optimal final property in concrete. So, without further ado, let's get started. Today, we have a couple things we aim to acquire, as with all experiments. Our main objective is to determine the water-to-cement ratio required for a cement paste with standard consistency and standardize the mixing conditions for subsequent tests like setting time and strength. Starting the experiment proper, first we gotta gather the things we need. That includes materials and equipment. For materials, we only need a kilogram of cement and some water, which will be measured as we go through the testing. For equipment, we need a Vicat apparatus, a device that includes a mold for the cement paste, a balance to weigh the cement and water accurately, a mixing ball and trowel, which we'll use to mix the cement and paste, and lastly, a graduated cylinder to measure the water volume.
Let's go. First step, we should measure the weight of the paper.
What's the weight of the paper?
It's 4. Next, we're gonna get 500 grams of this cement. To get the 500 grams of cement, dapat meron tayong 504 grams. Wow. More. Say more.
So, after weighing 500 grams of cement, we start with an estimated water amount of around 28% of cement weight. We then thoroughly mix the cement and water for a set time, around 3 to 5 minutes. We fill the Vicat mold with the paste and level it. We then lower the Vicat plunger and record the depth it penetrates the paste. Repeat steps 2 to 5 with adjusted water amounts until the plunger penetrates within the standard depth of 33 to 35 millimeters from the top or 5 to 7 millimeters from the bottom of the mold. Here are written procedures for you to follow if you'd like to try the test. Now that we gathered our data, let's head to computations. We calculate the water to cement ratio for each trial by dividing the weight of water used by the weight of cement. Then, we identify the water to cement ratio that corresponds to the standard penetration depth. After that, we compare our calculated data with specifications set by the American Society for Testing and Materials. As mentioned, the standard consistency of cement paste is achieved when the Vicat plunger penetrates the paste to a depth of 33 to 35 millimeters from the top of the mold, or 5 to 7 millimeters from the bottom. While the exact water percentage may vary, it typically falls between 26% and 30% by weight of dry cement. Here's the data we gathered from our experiment. By ASTM standards, all 3 samples have failed, but by IS specifications, our sample 3 managed to pass. While we cannot use this result as a basis to reject the whole brand itself, the sample chosen is partly not recommendable for future projects. There are other tests to conduct on cement to fully check its suitability for construction. On a side note, there are also other factors that could have affected this test, such as improper storing conditions and human error. So, why exactly do we need to conduct this test on cement that we're planning on using for constructing future projects? Well, using a standard consistency ensures consistent mixing conditions for further test, allowing for reliable comparison of setting time and strength between different cement samples. It also helps determine the optimal water content for good workability and final concrete properties like strength and durability. Guess that's all for today. Hope you learned a thing or two. If you're interested in more of our experiments, we'll be uploading a few more videos soon. So please, do subscribe and hit the notification bell to stay updated. Till next time!